Hi everyone. In this video I'm going to talk about number 14 from worksheet 7.6, and I'm also going to talk about several problems from worksheet 7.7. So let's start with number 14 from practice 7.6. You can pull this up if you'd like so you can follow along, but basically they give us a chart of all adults' favorite vegetables as reported from I don't know where. And number 14 is asking us to find the angle, to find the measure of the central angle for broccoli, which I've made a little bit darker here. So we need to find this angle, okay? So it says that broccoli is the favorite vegetable for 19.7% of adults. Okay. Anyway, so you can write percentages in this way that'll make it a little easier, I think. So 19.7% is basically 19.7 over 100. That's 19.7%. So you can draw it that way. And what we want to do is make it equal to this angle divided by all of the angles added together, which is 360. So what we have is a part divided by the whole equals a part divided by the whole, because 19% of 100 should be the same as this angle divided by the whole 360. So we can solve that way. Basically, I'm going to pull out my calculator here because I can't do this in my head. We're going to take 19.7 times 360. Okay, 19.7 times 360. So we just do cross multiplication here. 19.7 times 360 is 7,092. 100 times x is 100x. So we need to divide both sides by 100. Divided by 100 equals. Okay, and so that makes x equals 70.92. But on the problem it says give your answer to the nearest degree, so we're going to say 71. 71 is the answer. 71 degrees is about this angle right here. Okay? And now we can go to worksheet 7.7 and let's look at number 2. So we have a diagram, something like this, and number 1 through 4 is asking for different areas regarding this diagram that we have. So I redrew it. Number 2 is asking for triangle AOB, which is just this triangle right here. So I drew out AOB a little bit bigger because I don't really care about the rest of the circle at this point for number 2. We know that the angle O is 60 degrees. We also know that these two sides are congruent because they're both radii of the same circle, so they're both 7. Given that information, we know that these two angles are also congruent. So we know that those two angles have to be 60 as well, because if you take 180 minus 60, and whatever's left, you divide it by 2, it's going to be 60 and 60. So in order to find the area of this triangle, we need to be able to figure out the height. So I'm going to draw a dashed line down here, because we can turn this into 2 right triangles. And since we know this is 90 degrees, this is 60 degrees, this has to be 30 degrees. So here we are again with the 30, 60, 90 degree triangle theorem. So since this whole base is 7, we can say that this section right here is 3.5. And from the 30, 60, 90 degree triangle theorem, we know that the long leg equals the short leg times the square root of 3. So this long leg, the height of the triangle, is 3.5 times the square root of 3. Okay? Now to figure out the area of a triangle, you take 1/2 base times height. Okay? This is height. Oops, I did 3 dashes. Alright, so we need to take 1/2, and then the base is this whole part, so 7. 1/2 times 7 times 3.5 times the square root of 3. 1/2 of 7 is 3.5. So you can reduce it down to this. And if you put that in your calculator, I had done it already. Let's see what I got. Oh, can't find it. Ah, there it is. You get something like 21.217622 da 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 da. You can just write your answer to the nearest tenth. So the answer is going to be 21.2. And let's see if it gives us, it doesn't give us the units that they're measuring in, so you could put 21.2 units squared. And that would be the answer for number 2. Now we're going to talk about number 4, which asks us to find the area of this shaded region. Now we need to start by finding the area of the entire circle, which we'll use this formula. Area equals pi r squared. The radius is 7, so we need to take 7 squared, which is 49. And then we'll have to take that times pi to get the area of the circle. So 49 pi is the area of the circle. Okay, but we don't need to use the entire area of the circle necessarily, because we can just cut out this section right here. So it says this is 60 degrees, so in order to figure out just this section of the circle, we need to take 360 degrees divided by 60. And we find out that this, it'll result in the number 6, which means that this section is 1/6 of the entire circle. So we can simply take the area of the entire circle and divide it by 6, and that will give us this whole area right there. So this 49 pi divided by 6 is the area of just this little pizza slice. So now all we need to do is subtract the area of this inner triangle that we had found in number 2, which, just a reminder, was 21.2. We subtract that part, and that should be all that's left, is that little area right there. So your answer is going to be 49 pi divided by 6 minus 21.2. Let's look at number 8. We have a very similar problem, which is good, so we'll get 2 rounds of practice. So it asks us to find the shaded segment of this circle. This circle has different dimensions, however, but if you remember with our last one, we needed to find the area of the entire circle first. So the diameter of the circle is 1, so that means the radius is 0.5 or 0.5 or 1/2, however you want to write it. So the area of a circle is pi r squared. So r is 0.5. 0.5 squared is 0.25. So 0.25 squared pi. Or actually, I think the answer is written in fraction form. So let's say 1/4 pi, or you can say pi over 4. Either of those. All right, so that's the area of the circle. Now we need to figure out what percent of the circle is this little area here. Now, we know since it's a 90-degree angle there that it's splitting the circle into fourths. So here we have 1/4, 1/4. If we were to draw another line, we'd have 1/4, 1/4. So we need to take the entire area of the circle and divide it by 4 to get the area of that little triangle. So that means we have pi over 4 divided by 4. You might remember this from earlier classes that you've taken in math, but when you divide, you can draw it like this. Pi over 4 divided by 4, and let's put a 1 under it, is the same as pi over 4 times, and then you just flip this around. So we can simplify this with this problem, which is a little easier to handle, and say that it equals pi over 16. So this area here is pi over 16. Now we need to figure out the area of this triangle so that we can subtract that from this area right here. Now this is luckily just a straight right triangle, so we can find the area pretty easily. We know that the diameter is 0.5 or 1/2. Sorry, yeah, the radius is what I mean. So that means that this triangle has a base of 1/2. Also means it has a height of 1/2. So if you remember, to get the area of a triangle, you need 1/2 base times height. So that means you're going to have to take 1/2 times 1/2, here's the base, times 1/2, which ends up being 2 times 2 times 2 is 8, so 1/8. 1/8. So the answer to this shaded region is this area, pi over 16, minus this triangle area, which is 1/8. So that's our answer. Pi over 16 minus 1/8. Number 9, which is a nice one because it's quite a bit fewer steps than the previous ones that we've been doing. So it says find the area of the shaded sector of the circle. This is the shaded sector. When you see a 90-degree angle, you can almost assume, well, you can assume that that is going to be 1/4, because if you take 360 divided by 90, you get 4. So you know that these are in fourths. Okay, so we need to find the total area of the circle and then just divide it by 4, because this is 1/4 of that entire area. So remember, area equals oh, why do I keep doing that? I'm thinking of the area, or the perimeter. Pi r squared. R is 4, and 4 squared is 16. So the area of the entire circle is 16 pi. But we need to take that divided by 4 because we only need 1/4 of that area. We don't need the whole thing. So 16 pi divided by 4 is 4 pi. And that's our answer. It's very similar. It's a little bit trickier because it's not a simple 1/4 of the circle, but we need to figure out this shaded area. So we find the area of the entire circle. Area equals pi r squared. The radius is 6. 6 squared is 36, so 36 pi is the area of this whole circle. However, we don't want the area of the entire circle, so we need to take the degree of the angle, the inner angle, divided by 360, which would be the total. So that equals 10. So we need 1/10 of this circle. If we took 36 degrees and went around, we'd get 10 sections. So we just need one of those. So 36 pi divided by 10. Let's see how they wrote it in the answer. We just take this and simplify it a little bit. Let's take the top and the bottom divided by 2, which will give us 18 over 5. And you can either write 18 pi over 5 or you can write 18 over 5 pi. They're the same thing. So here's our answer to number 10.